Dear students, myself Dr. Angita Sharma Borua, presently working as Assistant Professor, Department of Education, Cotton University, Assam. Today I am going to discuss the applications of normal probability curve. Dear students, I hope you have the concept regarding normal probability curve. Here, I will not discuss the concept of a normal probability curve, but I will discuss the applications of normal probability curve. And I will try to finish my discussion up to 2 applications today. And after that, I'll complete the rest of the applications. Dear students, I'm going to start from the application number 1, which is that normal probability curve is used to compare scores on 2 different tests. Suppose there are 2 different tests. One is the test of mathematics, other is the test of English. So here in this instance, we can use normal probability curve in order to compare the scores between these 2 tests. Okay, so follow my instructions so that you can clearly understand my instruction. Okay, I'm going to discuss the example. A student obtains 80 marks in maths and 50 in English. Okay, so if the mean and standard deviation for the scores in maths are 70 and 20, and for the scores in English are 30 and 10, find out in which subject, maths or English, he did better. Here you need to compare 2 different you need to compare the scores between 2 different tests. One is test of mathematics and other is the test of English. And here in this problem, you may clearly understand that the raw scores in maths and English are given, and mean and standard deviation for maths and English are given separately. Okay, so I'm going to the solution of this problem. So dear students, as you all know about the formula for converting raw score into z-score and again converting z-score into raw score. So here we need to convert raw scores which we got in this problem. Suppose you can see the problem. We got the raw score 80 marks in maths and 50 in English. So here we need to convert the raw scores into z-scores, and we need to follow the formula, which was the formula. The formula was that z is equal to x minus m divided by sigma. Okay, so you please follow me. Okay, so here you need to convert the 2 raw scores. One is math and one is English. Okay, and now you put the values in the formula. You please see in here, like z-score in maths is equal to x1 minus m1 divided by sigma 1. So you put the values in the formula and you will get the z value, sigma value here. Okay, again you have to convert the raw score of English into z-score. Again you have to use the same formula, x2 minus m2 divided by sigma 2 is equal to, you put the values in the formula and you will get the sigma score as 2. Okay, so what we got here is that the sigma score in English is greater than the sigma score in maths. So we can tell that the student did better in English than maths. Okay, so you need to write, you need to conclude, or you need to interpret the thing. So you can conclude that he did better in English than in maths. Okay, so this was the application number 1. Hope you are getting my point clear. You can easily understand this application. Okay. So I'm going to the next application, which is normal probability curve is used to determine percentage of the individuals whose scores lie between two given scores. Okay, so here you need to understand that normal probability curve can be used to find out, to present the percentage of individuals whose scores lie between two given scores. Okay, so here I am going to the example. In a sample of 1,000 cases, the mean of test scores is 14.5 and standard deviation is 2.5. Assuming normality of distribution, how many individuals scored between 12 and 16? Here you can find out the number of individuals whose scores lie between the point 12 and 16. Here in this problem, mean and standard deviation is given. So again, you have to use the same formula, which is that z is equal to x minus m divided by sigma. So again, you need to convert the raw scores into z score. And you may know that which are the raw scores. Here the raw scores are 12 and 16. So you please convert the raw score into z score by putting the values in the formula. Okay. So what you got here, the sigma value, you got the sigma value here is minus 1 sigma. Okay, again you have to convert raw score 16 into sigma score, and by converting raw score 16 into standard score or sigma score, you got the sigma value as 0.6 sigma. Okay, now you need to present it in your, normal curve. Okay, so by representing in the normal curve the sigma value, we got the picture like this, which, okay, now you need to find out the percentage of cases from the normal curve table for 0.6 sigma and again for minus 1 sigma. Okay, and by looking at the normal curve table, you will get 2257 out of 10,000, or 22.57% cases lie between mean and 0.6 sigma. Okay, which you can easily understand by looking at the normal curve. Okay, how we are drawing the curve. Okay, so here is the portion on which 22.57% is lie. It means that from mean to 0.6 sigma, we have 22.57% of cases. Similarly, from mean to minus 1 sigma, we have 34.13%, which we can come to know by looking at the normal curve table. Okay, now the problem is that you need to find out how many percentage of cases lie between the points 12 and 16. Here we converted the raw score 12 and 16 into standard or sigma score, and by representing it in normal curve, we found out the picture like this. And now we need to, add the portion. Which are the portions? 34.13% and 22.57%, which we got as 56.7%, or 567 individuals. How we can tell 567 individuals? Because we have the number of individuals here in this problem. So converting it to round figure, we got 567 individuals out of 1000, score between 12 and 16. So I hope you are getting my points clear. So I'll discuss the rest of the applications of normal probability curve in the later classes. Okay, thank you so much.